in Turku, in Obo Academy, our partner, and today we will present some more results from VeriDevOps, and in particular we will talk a bit more about methodology. So something that we presented earlier, but these days we'll present a bit more formalized results about methodology, how it works, what tools we provide, and how they all work together. Then we give few examples like how to extract security requirements from the documents, specifications, then what to do with those requirements in the context of PLC systems, how to use EARS notation to work with that. We will have a short coffee break, and then we will talk about, let's say, security at runtime with specific anomaly detection mechanisms to predict, let's say, network security attacks. And also we'll talk about advanced root cause analysis techniques in the context of safety and security monitoring. So I will present actually this the first part of this material about overview of everything, and then I will give word to my colleagues Tanvir, Mikhail, Ivan to give more details about specific technologies. Right. So I will start with a short reminder about what we are, what VeriDevOps does, and what our challenges and progress so far. And then we'll start to unveil various other topics. Right. So what we deal with? So we deal with security threats, and we try to, let's say, help and remediate the risks for security breaches in software, specifically in software. This is due to the fact that security become more and more important nowadays. So as you know, many vulnerabilities have been discovered, and every day we hear about various security issues being found, and that can actually potentially lead to disasters situations, economical losses, but also a danger for human lives. So all industries affected, manufacturing, food, agriculture, energy, transportation services, water and waste management systems. So all the industry sectors are affected. So in our project, we have a couple examples with Fagor, Arasate in the industry in machinery building, and ABB in crane systems. So while security, we hear about security more in the users' context and regular people, but actually the problem is even more important for critical industries such as those represented in this project. Right. Also, what we can see that vulnerabilities are everywhere. So they are not only software, but they actually hardware, network, and in software we actually find more and more critical vulnerabilities, those that represent the highest risks for the systems. So that is to say that, I mean, we need holistically address security and deal with both networks, physical layers, operating systems, various frameworks, platforms, and also applications, and that needs to be holistically managed. Also, what we see that software vulnerabilities have a larger portion of, let's say, they represent the highest risks, because we see in various reports that many times software represents this kind of door for the attackers to carry out specific malicious events. Right. So the problem with software, first of all, it's going really fast. It's really released in a very fast pace nowadays. So it's actually to cope with high demand for new services, new features, to better serve the users, address the feedback. So we want to produce software and release it as frequent as possible and more frequently. In the meantime, that represents a risk because we need to make all quality procedures in time, more and more automated, and discover all vulnerabilities beforehand, before systems goes in production. But also, if vulnerability discovered, we need to address it as soon as possible. However, as we see from the practice, is that taking care of these vulnerabilities takes enormous amount of time. So first of all, I mean, somebody on this graph will actually see some reports from open web application security guidelines. What they actually showed in this graph for life cycle for security vulnerabilities is that from the moment the security vulnerability is discovered, it could be by developer, by external people, by hackers, by specific authorities, audit organizations. From the moment it is discovered and patched, we go through various risk levels. So vulnerability should be known, right? There is a risk that somebody would actually exploit this vulnerability for a longer period of time. During this time, I mean, developers or producers, vendors have to do a lot of important things to patch this vulnerability, release it, and distribute to all users. So, and still we can see that in some cases, not all users actually like update their system with the security patches, and so the risk could not be zero even if we kind of did everything. So the idea is that this period of time is rather lengthy, right? In many cases, it can reach even 6 months. So to patch vulnerability. So many companies even do not actually update their systems. Because of various reasons. But there is actually a need to shorten this period, make these updates and fixes more available. And so this requires a lot of efforts, both from research side and also from the software producer side. Okay, in many reports we see that number of vulnerabilities grow tremendously. We have longer period of times to remedy situations with breaches and fault audits. Some vulnerabilities take or even two months to be close some discovered vulnerabilities. Many organizations do not care about vulnerability, do not scan for vulnerabilities. Many organizations run so-called legacy systems for those that are not updated, and there is no, it's too expensive to replace the systems. And so there's a lot of manual work in this process for patching, discovering problems, patching that. And this needs to be remediated somehow. Right, so our challenges. Security is something that has to be addressed in all industries: internet, transportation, railway industry, 4.0, manufacturing. The number of security scenarios explodes, and actually they are both on all layers of software systems, on architectural level, on infrastructure level, on deployment, it's also a people issue as well. And so it needs to be addressed somehow holistically. So vulnerability can cause a lot of losses to end users. So they can have a high economic impact on companies, on society, on people. And what we believe and want to reinforce that those security mechanisms are built in to systems. First of all, addressing them from very early steps of development, from requirements engineering, right? So understanding rightly what are the security risks, what are possible vulnerabilities to be addressed, what are the best scenarios to cover and best practices to apply. So it is often said that security is very difficult to retrofit into design, meaning that design is somehow very much important when we consider the system that should be secured. So, and with modern practices, currently we see that continuous integration, continuous development is more and more important to quickly address needs by the users, market changes. So we think that this security mechanisms have to be integrated and support this continuous integration and continuous deployment practices. Right. So to give like a very short overview in kind of more kind of landscape for our project. So we see that we have a lot of databases, a lot of requirements for security coming from vulnerability databases, standards, like from industry, we know about standards like 62443. There are specific guidelines by many companies, organizations, countries on how to develop secure systems. So what we see on the other side that we have a more and more DevOps practices when we actually have a very short iterative cycles between development steps and operations, where the feedback from operations is given back to development and needs to be addressed very fast. And this goes through many automation steps. However, if we talk about security, in this context, it is still very much manual work because it takes a lot of time for security specialists to analyze security requirements, check how that security requirements have to be implemented in systems, and what needs to be done to prevent various attacks and be able to localize and fix various vulnerabilities in the code and redeploy the systems. So it takes a lot of time. And the goal of our project, so what we represent here, is that we want to automate as much as possible these processes. So going first and kind of paying a lot of attention into formalization of security requirements. So we want that what we obtain as a kind of guidelines for localizing various vulnerabilities, developing specific functionalities in accordance to security rules should be formalized in such a way that we can automate scanning for vulnerabilities, automate monitoring, automate detection of anomalies in system behavior, but also during the development side, the development time to automate tests, design checks, and integrate everything into CI/CD practices. So our project addresses all these aspects, and so what we want is to build a framework. We investigate a lot of new and novel methods for formalizing security requirements, generating specific trace monitors that address safety and security, locate root cause analysis, in defining security flows in the code and designs, generating test cases that address all of that in specific settings. So our goal is to improve significantly productivity within the continuous integration delivery processes to build trustworthy systems. Right. Where we are right now, actually, we already at the final stage of our project when we actually developed quite a lot of tools, and we currently thoroughly evaluate those tools by running various experiments with our partners, ABB, Fagor, and some internal experiments to benchmark the performance of our tools. And also, we would like to actually bring to community a bit more results and try to discuss all these methods, tools, and our results with the larger community. Right. To give you key results, we have about 10 use cases from our industry partners. We have around 12 tools to talk about and about 20 papers that discusses our scientific results that we also invite you to check. Our key innovations so far, we have specific NLP data sets and models for requirements classification and a recommendation of security guidances. We have a machine learning based anomaly detection that we will partially see today. We have metamorphic testing, vulnerability detection at early stages, and much more. This is a brief overview of what we have. If you have any questions, please raise your hand or anything, give us any sign from the space. So, okay. Otherwise, I would continue and give you a bit more details about what we have about VeriDevOps, and also starting from this cosmic view and digging down into particular technologies, and give you a bit more details about various things that we have and how it's all chained. So I will continue with methodology overview. Right. So to remind you, we deal with DevOps, and so it's development operations. It's specific, let's say, profession right now, because we want in development process actually address both development operation sides and have a shorter release cycles, let's say, when we, let's say, from development to operations, we go really fast and also collect feedback through monitoring. And that's actually feedback goes back to development stage, where we actually bring new features, like fix some particular issues discovered at operations, and go back and actually kind of develop the system again and again. Actually, we work with what we called DevSecOps. So we have security, which is kind of a bit orthogonal to all of that and should integrate in all of those stages of DevOps. So, and it starts with identifying security requirements, right? That can come from specifications, from guidelines. So those specifications need to be checked for quality if they are clear enough. They are unambiguous, atomic, and represent the concrete guidelines for developers to implement the system in a secure way. And this goes with the help of various natural language processing methods. So to obtain what we call security models, it's kind of design that are formal, structured, or semi-structured, that could help actually to go and generate some specific test cases to verify system, or generate specific monitoring rules, so that at operations we can check that system behaves in a way that it was specified, right? If there is something that discovered in terms of anomaly detection, kind of anomalies during operations, there should be somehow countermeasures, okay, that are kind of applied on running systems. So this information can also serve to generate specific test cases to prevent specific things from happening. so localize any errors like causes for anomalies, localize vulnerabilities, and let's say put this tasks in a backlog for development so that developers address that in development phase. Right. Okay. So this is kind of overall picture that is I would say very classical, what concretely our project does. Okay, what kind of tools it provides, and to answer this question, we can look in this next diagram when we discuss methodologies as whole, right? So we have a set of tools, like here we see file C, we'll see meta tester, graph worker, MMT. So we have various methods that are actually given on this diagram in greenish boxes. We have also various artifacts that are provided, like security requirements could be in input, then vulnerabilities attacks could be also in input, data sets for training various tools could be the input, source code for system under test could be the input. Okay, so we go from requirements formalization stages to prevention and development, to protection to operation. And so this formalization step is one of the kind of central piece, because it gives inputs to development phase and operation phase tools. And various tools have different inputs, but the kind of original input are pretty much the same for all the tools, like security requirements documents, functional requirements documents, that through several steps like NLP or kind of manual translation are transformed in specific artifacts for specific tools, like functional model, state machines, and UPAL. So for formalized security requirements with TCTL, that also verified and for conformity. Right. These security requirements can also serve to configure specific tools like Monty-Marsh monitoring tool for detecting specific vulnerabilities. Right. Here we have a set of tools. We also can illustrate our methodology by a set of specific tools. So in the DevOps environment, requirements come into specific what we call issue trackers, like GitHub would have one of those. These issues should be analyzed. So it's done most of the time manually by the project managers or developers that classify them. So our tools like NullApps, like Archon, can help actually automatically, let's say, verify or qualify those requirements for how good they are, if they are well written and understandable, or do they relate to security. So we can obtain structured requirements that can be transformed automatically or semi-automatically into specific metamorphic relations, let's say. So specific technique for metamorphic testing, to applying metamorphic testing. So that it could be translated in specific format for generating verification code for PLC, so programmable logical components for industrial applications, or transformed into recommendations through specific recommendation engine and application of specific like automated test cases, giving the database of existing tests. Right. So also the semi-structured requirements can go and apply to monitoring rules and Monty-Marsh tools and early tools by OBO can actually create specific alerts and countermeasures so that the developers and kind of DevOps specialists are informed about various security anomalies. Right. To exemplify that, here's a small example that we showed you previously, but I think it's worth to be repeating. So here we have, for example, a requirement the system should be protected from brute force attack on SSH. And when it comes to the issue tracker, the issue tracker can call specific tools like nullabs, like Archon, and detect whether this issue is related to security. So here in this case, I mean, our tools automatically detected, okay, this is related to security, and they proposed to apply specific guidelines from the STIC database. So this STIC database is security technology implementation guides that give specific, very concrete checks and fixes, scripts, so that to protect the systems. And in this particular case, our system is running on Ubuntu operating system, and if we want to protect over brute force attack with Ubuntu, there is a number of rules or let's say recommendations what to do, and that comes with concrete test cases, concrete actions to be done, and so they could be automatically applied based on analysis of those recommendations. Right, so this is a short example. We actually came with a number of recommendations. Here is 4 of them. So what we want to promote is that security requirements specification in kind of formal or semi-formal, structured or semi-structured forms should actually be addressed in the DevOps process properly. So this means that it should be specific steps, specific people, specific processes, and also tools to help to analyze those requirements and assist in creating tasks for developers in the right way, so that are they concrete and like unambiguous, so that security is addressed properly in development stage and during monitoring stage of DevOps process. So these security requirements has to be addressed in entire DevOps process. Meaning that when we plan some activities, we should consider security issues, security vulnerabilities. When we develop something, we should address testing for specific security issues. When we monitor and want to give feedback to the developers, we also need to address what we discovered as anomalies. Right. For testing techniques, so currently we have quite a number of automated testing techniques. Basically, it comes more to the automated test execution as a quality gate in DevOps process. So what we want to promote is also generating the test cases and setups based on security requirements and various relationships that we discovered in specifications. So the testing tools cover all security requirements. In monitoring systems, what we want is to detect security threats, but not only those that are kind of already been specified, right? But also detect anomalies and analyze these anomalies properly, so that we can actually bring new, let's say, requirements that upcoming emerging requirements, and addresses emerging security concerns at the development stages. Right. So this was kind of short list and short overview of our methodology. So, in case anyone has any particular question, so we'll be happy to reply. You can contact me or my colleagues, and we'll be happy to discuss that. So, right. The last thing that I wanted to talk today, and maybe to show you some small